Okay. Let me just test the audio. Yes. So it has started. The session has started. Let me just test the audio. Okay. So it is working fine. Audio and video both are fine. Okay. So welcome to this second session on the topic sockets. And we will get started in a while. So in the last session, we discussed about what are sockets. We discussed about the client server architecture, and we also saw a small code implementation of how to implement that client server architecture using sockets and threading in Python. We also understood some important concepts of threading, basics of threading, and we implemented those as well, right? If you have not watched the part one, I would suggest you to go and find the part one of this series and watch it, so that we have created a very basic server client architecture, and we also implemented a client and a server on the same machine, where client was connecting to the server. Different multiple clients can connect, so we implemented, because we were on the same machine, we tested client and server on the same machine, and we sent a message from the client and it was received at the server side, right? We also implemented how we can implement the multiple clients, how we can handle multiple clients on the server using the concepts of threading, right? So if you have not watched the first part, I would highly recommend you to go and follow the first part, okay, before you jump into the second part, because some codes are uh, basically, I mean, I will try to build on that code, okay? So it's very important for you to go through that previous session. So I will just drop uh, the link of that session in the comments or in the live chat, so that you can just access it, right? And yeah, you can also go to the channel and find the part one for this, okay? So it is, the title is socket programming in Python. If you find it, if you search it on the channel, you'll get it. Okay, so let's just go through and revisit the code that we have done in the last session. Okay, so we implemented two scripts. One is the client, as you can see on the left side, and one is the server. Okay, so if you see in the server, we had two functions which were, we started with the port number, the server, the ADDR. We created a server object, and then this was format as was the encoding part, and then we basically created a start function where we started the server to accept the incoming request. We called the starting function, and whenever a client accepts, we started a new thread or a new function. Okay, so this handle client was basically responsible for handling all the clients which are connecting to server in a different thread. Okay, so that's how we implemented multiple clients connecting to the same server. So two functions were there with some properties. We also understood what is this port, and we also understood what is how to create this server object, and then we also implemented a threading concept. We also binded this handle client to this thread object, right? And that's how the server part was implemented. Okay, and on the client side, we did very basic stuff. So we just created a client object and we gave the server credentials and port number and client dot connect, and then we just gave some basic messages to begin with. Okay, so we sent hello world and the client just sent, right? Okay, so now what we need to do is, so our communication part is taken care of, right? So we have the server and we have implemented that there will be client 1, client 2, client 3 and so on, client n. So these can connect to my server, right? And they will connect and they will send a request to connect, and the server will respond with a message back to clients, right? So that's how this communication is established between client and server. This we have implemented. Now what we need to understand in this session is some properties, because this method of sending messages is not very uh, what should I say, it's not very efficient. Okay, why? So why, we will understand. So in the last session we just created this parameter. If you see, we created this parameter called header, right? So what was this header, we didn't discuss in the last session, but it is very important if you consider the communication between client and server, right? So if you see, I have used this header function in the handle client method, where whenever the client connects, I am creating a connection, I am passing that connection object in the handle client, and I am receiving the data on the server side, okay, using connection dot receive, and in the receive I have passed header as a parameter. So header, in my case I've defined it to be 64, right? So head connection dot receive header, then dot decode format. So this is how you get messages of the client, right, handled on the server side. This is how server receives information from the client, right? Now what is this header parameter? So we discussed in the last session that if you have taken header to be 64, that means your server is expecting your client's messages to be of length 64 bytes. Okay, so you know what is 1 byte? 1 byte contains 8 bits, right? So at a time your server is expecting your clients to send how many bytes of information? 64 bytes. Okay, so 64 bytes of information your clients can send, and it is not maximum, it is fixed, it is fixed, it is fixed 64 bytes. Okay, so every time a client connects to the server, and so let's say in this example we started with this message, right? Message was hello world, then we encoded this message in the UTF-8 format. So what this will convert, what this will do, this will create the byte representation of hello world, because whenever you are sending the messages from client side, it is always sent byte by byte. Okay, byte wise streaming is happening. So if you see these two, we also discussed about the parameters given while creating socket object, right? So this is the IPv4 socket, and this is the method which is socket dot stream. So we want the streaming socket. Okay, so whenever the data, any data hello world is given, first let's say if I send hello world, first h will go, or I mean it's 1 byte of data will go. So let's say h is 1 byte, or every character is 1 byte. Okay, let's assume that. So first h will go, then E will go, then L will go, then again an L will go, then O will go, then a space will go, then capital W will go, followed by O will go, R will go, then L will go, and then D will go. And that's how all the bytes would be sent to the server side. On the server side, you accumulate all the streaming bytes which are coming to you, and you decode them, and you decode them using UTF-8, and then you convert them into a string format. And that's how on the server side, when you see connection dot receive header dot decode. So first it will, how this will happen, H will go, E will go, L O space WORLD, and byte wise. This byte wise data will be stored, decoded, and then will be stored in the message variable, right? So what is important to understand over here is, the important point to note over here is that the streaming is happening, or the connection, or the transmission of data is happening byte wise. Okay, it's not like you are sending hello world at once. So it is happening byte wise. First one byte of data, then the next byte, then the next byte, then the next byte, right? So that's how the streaming is happening. So now, because the data is happening on a byte wise level, it becomes very important for server to understand how many bytes of data the client is sending, right? Because server has to know that, basically it should know that, or it should know what to expect from the client side, right? So that much information only the server will read. It will not read, if you send 128 byte long string, okay, so it cannot read 132, or it cannot read 126, or it cannot read 120. Otherwise the message will be the message won't be complete, right, at the server side. So it has to, if you are sending 128 bytes, if the client is sending 128 bytes of data, then it becomes very important for server to understand that, okay, this client is sending by 128 bytes of data, so I need to create a space of 128 bytes, or I should read 128 bytes at least, right, for me to process the complete for the server to process complete information sent by the client. It should know that, okay, I need to read 128 bytes. Okay, so let's just discuss this on the whiteboard. So you have client, okay, and you have the server. Now the server is reading and client is sending. It can also happen, server can also send data and client can also read, but as of now we are taking the very basic architecture in which client sends the data and server is basically reading and responding to them. Okay, uh, just reading as of now, not responding back to them. Okay, so client will send some let's say hello. So this will go in a stream. Okay, so first H, then E, then L, then L, and then O. Okay, so this is how first H will go to the server. It will get, now the client will say that I am sending you 5 bytes of data. 5 bytes of data. So the server will understand, okay, first I have to, it should read 5. The client will send that how many bytes of data I'm sending, and then the client will send the data, right? So first the server will read the first number, which is basically the number of bytes it has to read, and then it will just read the number of bytes, the exact message, right? So let's say then after this client sends another message. Okay, so then it says the second message goes like hello world. Let's say this data is 20 bytes. Okay, so now the first thing that the client needs to send is this 20. Why? Because server has to know through some mean that the client is sending 20 bytes of data. Right now what we have done is we have just hard coded header to be 64. So this is fixed, this is fixed, this is exactly fixed to be 64. So you cannot send, I mean, whenever the client sends data which is more than 64, there will be some error in the reading part. Okay, so we have to, the server, every time the client is sending some data, so the server exactly needs to know how many bytes of data it is sending. So what should be the ideal case to handle such cases? What can be the approach? So approach, we have it's very simple. So the first thing that client needs to do is send a data, send a number, send number of bytes of data to be sent. Okay, then the second thing, send the original data. So the communication should happen in two parts. In the first part, the client should send that, okay, I'm sending 20 bytes, 5 bytes, 10 bytes, 100 bytes, 1000 bytes, whatever the size of the data is. Okay, so the first thing is that, and the second thing is it should send the original data, so that first the server will accept that number, and then it will say, okay, this client has sent let's say 128. So server will know that, okay, the next message has to be a message or the original data which is 128 bytes long, right? So what we can do is, first, how we will implement this is, first, from now in our communication, this is client and this is server. So first the client will send, let's say 20, okay, to the server, and then it should send the data. Okay, so now in the first step, the header, that is why I have defined this header variable. Okay, so I have defined this header variable because first time I am sending a number, right? Whenever the client connects, and the first data that it sends is the number of the bytes of which is the number of bytes present, how many bytes the message data represents, right? So it's a number. So a number can be 20, 30, 40, 120, whatever. It can depend on it. The constraint for this number is basically how many characters you are allowing the client to send, right? So for example, client can send hello, right? I'll show you. So for example, client can send hello, and client can also send hello like this, or it can be even longer, right? So obviously this hello is not same as this hello, right? So the data represented in, obviously this will be in the data size in bytes, or the data that needs to be sent over the communication in byte representation. The number of bytes contained in this hello would be greater than this hello, right? Obviously. So the number basically depends on how many character limits you are putting on the data. Okay, so let's say this is a chat application. Okay, so you have allowed 264 characters to be the limit of the message. Okay, or let's say you have given 1096 characters as the message limit. So these 1096 characters will basically determine how much is the size in bytes of the message. So the maximum it can contain 1096 characters, right? So you will have to see how much bytes a 1096 character long piece of information is taking. So that much data, that much number is basically the maximum that the client will send on the first time. Okay, so so you get the point, right? So the first, I mean, for our simple applications, it's not gonna exceed let's say 250, let's say I put a threshold 256 characters. Now you can create a string of 256 characters and see how much bytes it is taking, how many bytes are represented in that string. That number, let's say this comes out to be comes out to be 256 character long message. Let's say this comes out to be 512. So let's say 256 bytes, 256 character long message is taking 512 bytes. So this 512 is the number, right? Which basically which the client has to convey. So how can this 512 be represented? How many bytes will 512 take? I mean, you have to send 512 maximum. I mean, it can range from 0 to 1 to 512. The number of bytes are that the clients need to send. I'll tell you in very simple. Okay, so let's say you have messages, okay, and these messages are sorry, these you have put a limit that these messages are 256 characters long. Maximum the message can be 256 characters. So now the client needs to send what does the client send for the first time? First time it will only send how many bytes of messages, how many bytes are contained in my message, right? So your message can be anywhere between 0 to 256 characters, right? A client can also send an empty string that will also take some space, but a space is also like it will contain 1 byte at least, right? So to maximum 256 character. So let's say the number of bytes contained comes out to be in the range 1 comma 5112. Okay, now you will be sending the client is, if you see the previous discussion, the first time what the algorithm is doing, the client is just sending the number of bytes of data to be sent, and then it sends the original data, right? So if this is if it is sending data as the message, it is first sending that it is 20 bytes, then it is sending the data, right? So when your message is 256 characters long maximum, you can have 0 to 256 characters as the message, though the byte length would be 1 to 512. So the client has, the first message that the client sends to the server is any number which is between 1 and 512. So it can be 1, it can be 2, it can be 3, it can be 4, and it can be 512. Why 512? Because 512 was the number of bytes present when the message was of maximum length, which is 256 characters. So it has to be in this range, right? It has to be in the range of 1 to 512. So you will have to see that how much space 512 takes, right, in terms of number of bytes. So if let's say the number of bytes taken by 512 is 3 bytes. So that is why you need to define header with a range. Okay, So let's say you get 3 bytes as the maximum number, then you can define this header as, for the safer side, you can define this header as 8 bytes. Okay, I have defined it to be 64. You can define it, you can do this calculation, and based on this you can define the header size exactly. And why do we need this header size? Because the client is sending, for the first time it is sending the number of bytes which is present in the original data, so that when that number is received on the server side, it has to know how many maximum bytes it has to read, right? So that's how we came to this calculation. Okay, I hope it is clear. Let's say my message was 256 characters long. I will have messages which can contain 1 to 256 characters. Okay, now the number, the first time the client will connect to the server, it will say I am sending 1 bytes of character, 2 bytes of 2 byte. I am sending 1 byte of information, 2 byte of information, 256 byte of information. Okay, so this basically is a number, right? So this number will also take some space. This number is when the client will send, okay, this is 20 bytes of information. 20 is also an information, right? So you need to see how many bytes 20 is taking. Okay, so the maximum, let's say for 256 character long, let's say it takes 512 bytes. So a client can also send 512, right? Because 512 can be the number of bytes present in 256 characters long message. So then you will see how many bytes is 512 as a message. So let's say it comes to 3 bytes. So then you can define your header to be 8 bytes, to be on the safer side. Oh, if you're so confident that it's not going to exceed 512, then even 3 byte is enough, but just to be on the safer side, we take 8 bytes. Okay, so that is how we calculate how to take this header information, right? Now the second time the client doesn't needs to send this. Why? Because in the first time when the client is initiating the first connection, that time only it has communicated that the next message is going to be 3 bytes, 4 bytes. So you can, whatever you receive on the first time, you can just pass it on the second attempt. So first attempt, when the message is getting received on the first message will be the number of bytes. So then you will pass this header, and this header will come from the calculation that we just discussed, right? The second time you don't need anything. Why? Because this message only will give you the hint about the number of bytes that are coming as that the server needs to read, right? So that message which is coming in the first time only contains that information. So that message only will get passed into the connection.recv method. Okay, so we will see the implementation now. I think this funda is clear. The first time the client is sending the number of bytes it is sending, okay, and the next message, and the second message is the original data. So first time it's just a number that also has a byte representation. For that we saw how to calculate, right? And after calculating you can define it as a constant. First time it will get read. Let's say the client sends 64 bytes. So 64 is a number. Let's say 64 takes 2 bytes. So the client first time will receive the 2 bytes, and then it already knows that the next character is 64 bytes. So 64 will be passed into whenever the client will receive the second time, it will pass that 64 as a parameter to the receive. Okay. Okay. So I guess this was clear to you. We will implement now what we are trying to say. Okay, so I'll go to my server script only. Okay, so the only change that I need to do is, so connected is true. And the second thing that we need to mention is we also need, whenever we initiate this connection, right, we also need to implement the logic to disconnect the client, right? Because if you don't disconnect, then there might be some issues, right, on the server side. Because if you have not cleanly disconnected from the server, you just let's say the client closes the application and it just doesn't, if you have not implemented the disconnect logic, then it will show as connected, right, and it will take up the resources on the server, right? Okay, so because in the last script we were just interested in reading what the client is sending, we took it as a message. Now we know that the first character that the first thing that the client will send is message length, right? So I am defining this first receive from the connection as message length. Okay. So now if message underscore length, I mean if there is some content in my message received from the client, then what should I do? So I will say message underscore length equals int message underscore length, right? Because it's a number. So client will say 20 bytes. First time when it connects, it will say 20 bytes, 40 bytes, whatever. Okay, so that is a number. So I need to first, what I'll do is I will read it. Then if it's a valid message, if it contains some content, then I will say int of message length equals int of message length. Okay, this is done. Now the second message will come from the client side. The client side will say, client side now will send the original data. So now comes the message. So I am writing msg CONN dot recv, same way like we did earlier. So I am receiving the second part. Now inside this parameter, what should I give? I will give the message length, right? Because message length only was the number of bytes the data contains, right? So once that message is communicated to the server, I will use that integer only as a parameter inside recv. Initially I was giving header. Why? Because to be on the safer side, I am saying the numbers which the client is sending for the first time will not be exceeding 64 bytes for the safer side. You can calculate it, right? You can calculate it using the methods that we have discussed. But to be on the safer side, I am just giving 64. Then this message length, so let's say the client sends 20, because the information that the client is sending is 20 bytes. So the 20 will get received, I convert it into integer, and then I pass that into the con.receive, and this client will now the server will read exactly 20 from the client, and the information will also be 20 bytes, so there will be no discrepancy, right? Now I will implement the disconnect. Okay, so I am saying if message equals I'll give it a string. So this can be the disconnect message. If message equals disconnect, if client sends this disconnect message, then I will say connected equals false. So in the last session we didn't discuss why this connected variable is taken, right? So initially when the thread gets started, we take connected to be true, and then we say while connected, which is same as while true. We keep on looping in this. So whenever the client sends that number of bytes, it will read that. If that is valid, it will go inside, convert that into integer, and receive those many number of bytes from the client. Now if the client sends this as the message, which is disconnect, then I should make connected as false. And then so when the connected is false, while connected will be while false. Okay, so that is when it will come out of this while loop. Okay, so if message equals disconnect, client equals false, connected equals false. Okay, so I'm just printing if message is not equals disconnect, it will not execute this and it will print the message from the client, right? Okay, now if the message was disconnect, it will obviously come out of it will come out of the while loop, and before doing that I will just close the connection. Okay, so first it will read the number of length. Okay, then if it's a valid length like 20, 30, whatever, if it contains something, convert that into integer, pass that into con.receive, and so that those many number of bytes can be received as the message. Now if the message is disconnect, if the message is factorial disconnect, then make connected false and close the connection before you exit this while loop. If the message is not disconnect, then obviously connected will not be false and this print statement will be executed, right? This print statement will be executed. Okay, and I'm closing the connection, right? Okay, so this is the exact side on the server. So I have not defined this. Let's define this this as a disconnect message so that we have it as a variable. So I will give it a name. Disconnect message equals, I will give this, and here instead of comparing like this, I will give if message equals disconnect message. Okay, it's if message equals disconnect message, then make connected as false. Okay, I've just defined it as a variable so that you can change it. Whenever you change here, it gets automatically it gets applied everywhere, right? Okay, so I think now the server side looks good. First it is expecting the client to send the message length, then if it's a valid message length, convert that to integer, receive those many bytes. If the message was not disconnect, print the message. If it is disconnect, if it is disconnect, make the connected variable as false so that it exits out of this while loop, and connection is also closed and it is it exits. Basically that thread gets exit, that thread is killed, right? So that the resources are freed on the server side. I mean, if you don't close the connection and if you don't exit out of this while loop, you are just taking resources up, right, on the server. So that is how you handle the server side. Now let's come to the client side. Now on the client side, initially we were just sending this message which is hello world, and then we encoded it and client.send. This is just to mimic the enter thing so that whenever I enter, it should just send the message. So now we will just comment these, okay, because this is not what we are sending. Now the client is doing some different functionality, right? First it is sending the number of bytes. The number of bytes it basically the data contains some bytes, so the number of bytes it has to send. So I'm defining a send message on the client side, and it takes a string as a parameter, right? So first what I should do, message equals, what I'll do is msg dot encode format. So first I'll get the byte representation of the message. Okay, and you can get the byte representation of any string by calling dot encode, and inside dot encode you can give this parameter which is utf-8. Okay, so I've given format is utf-8, so message dot encode format. I'll give you an example also. So let's say let's say I invoke Python. So I have taken two examples. So let's say I take the string as geeks for geeks. Okay, and I want to know how many bytes it contains. So I'll give len. I want to find the length in the number of bytes contained in geeks for geeks dot encode, and inside the parameter you give utf-8. Okay, if you print this, it prints 12. So 12 number of bytes are contained in this string geeks for geeks. So if you count the letters also, it comes out to be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in Python, one character takes 1 bytes. I mean 1 G or E and K, F. One character is taking 1 bytes. So so that is why geeks for geeks, because it contains 12 characters, it is taking 12 bytes. Okay, but it can differ. It can differ because this is the ASCII representation, right? If you see this example, which is len of this strange character, which is basically, I guess, a Chinese language character. So if you do this, then this, because even though this is a single character, it won't take 1 byte. So let's just try it out. I'll paste it. Okay, I haven't copied it. So copy. Let's try this and find how many bytes this strange character requires. Yes. So now it prints 3 bytes, even though it's a single letter, right? It is just a single letter, like G or like E or like like K, like F. Even though it's a single character, still it is taking 3 bytes. So certain characters will take more space, right? So that I guess you get the logic, how to find the number of bytes the string contains, right? To find the number of bytes my message contains, I gave msg.encode. Inside the encode I gave utf-8, and then I store it in the message. Okay, now because I know the length, I will give message.length equals, I will just call len on message. Now this is the what is this message length? This is the number of byte my data contains, right? Now I'll create a variable send length equals str msg underscore length, okay, dot encode format. Now why I have done this? Let's say the message is hello world. Let's say this is the message. So first it will encode it in the byte format. Then it will know how many bytes are present in the hello world message. So that is your message len. Now this needs to be sended. This needs to be communicated. The client will communicate this, right? So this number I have encoded in bytes. First I have converted it into str. So let's say this contains 20 bytes. So 20 has to be sent to the server, right? So I have converted 20 into str and I have encoded it in the byte format, same way that I did the message. Okay, so now that 20 is in the byte format. So now I will make it 64 bytes. Why? Because the header is defined to be 64 bytes. So first time if you see my message length, connection is receiving this header number of bytes, right? So it is expecting me to send 64 bytes. But I'm not sure whether the number that I'm sending is 64 bytes, right? It can be 20. So 20 will not take 64 bytes. If you just check, uh, we'll check the number of bytes present in 20. So the server will send 20, right, as a string. If you check the number of bytes, it is 2 bytes. It can also contain 203. That can also be the length of the message, right? That will take 3 bytes. It can also contain whatever, right? So to be on the safer side, I have taken 64. I also showed you the calculation for that, okay? So right now it can, let's say I can maximum go to 1048. Okay, so if 1048 is the number of bytes, then the length of that would be 4, right? So but my server is expecting 64 bytes, so I need to create a standard 64 byte message, right? So what I'll do is I will create a byte, and I will use spaces. So I'm just padding spaces. And how many times I'm padding? I'm padding header minus length of send underscore length. Okay. So now let's say my message is hello world. Okay. My message is hello world. I encode it into bytes. How many bytes it will take? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It will take 11 bytes. I need to send 11 now as a string. So I convert, so first I get the length, which is, so now my message length is 11. I convert that into str and I encode it again in the byte format to be sent over the, to be sent to server, right? So now my send length is a byte representation of 11, but my byte representation of 11 will only take 2 bytes, but my server is expecting the first message to be of 64 bytes. So I need to pad 62 bytes extra, right? I have 2 bytes. My server is expecting 64 bytes. So I need to pad 2 bytes extra. How I got 60, sorry, I need to pad 62 bytes extra. My server is expecting 64 bytes. My message is how many characters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my message was 11. 11 will take 2 bytes. So I need 62 more bytes to make that message as 64 bytes, right? So how I got 62? I subtracted the length of the number of bytes in my send length from the header. So header minus send minus length of the send length. So send length length would be 2 bytes. Header is 64 bytes. 64 minus 2, 62. So I have added 62 spaces as number of bytes. I have padded 62 spaces to the send length so that my message becomes, so that my first message becomes a standard 64 byte long message. Okay, no matter the number I am sending, no matter what number I am sending, it will make a standard of 64 bytes by padding zeros, and this will make sure that I have a message of 64 bytes. So now what I need to do is, first, now I have the number of bytes and the original message in the form of message, right? So my the number of bytes contained in the message is already 11, which is I'm sending as a str, but it just to make it in the standard 64 byte, I did this. So now what I'll do is I'll first send the length in number of bytes, send length, and then I'll do client dot send message, the original message in bytes, right? So first, what it is doing, client dot send message. Okay, so first it is encoding the message in byte format. It is finding the length. Let's say it is hello world, so we get 11 bytes. We encode 11 into string format. Then we pad the number of bytes because 11 will only take 2 bytes. So 2 bytes plus 64, 62 spaces gives me 64 bytes is a standard message. I send the length and then I send the message. Okay. So now what should be done? Now I'll just call this send message. Send, let's say I pass hello world. Sorry, this I'll remove. Now you can send any message, it will be handled. Just the thing is, header should be 64. If you're padding, I mean, it won't go beyond 64, but that can also happen. Hello, Utkarsh. I'm giving my name. And I need to give input before this so that I have the enter functionality. After each message, it should give me the enter functionality, right? And let's give this third message as disconnect message. So I'm sending hello world, then I'm sending hello Utkarsh. Then I should also disconnect on the server if I receive a disconnect message, which is, so I'll need to include this in my client side. Okay, so disconnect message is already this one, right? So first I'm sending hello world, then I'm sending hello Utkarsh, my name, and then I'm sending the disconnect message that disconnect me, right? Okay, this looks good. The client is done, server is done. Let's execute. So I will exit from here. I'll go to desktop, go to tutorial, and I'll execute the server. Let's check the name of the script. It is server.py. And execute. It's saying server is starting. Let's make it a bit small. Okay, so this is my server running, right? Let's execute one more. cd desktop, cd tutorials. Okay, let's make it like this. I hope it is visible. Okay, now I'll execute the client.py. Okay, so it is sending 11 bytes of data. I mean, the first message is 11, then it is sending the message. Okay, I guess I have not saved it. Header is not defined. Okay, header is not defined. Okay, I'll restart the server again. Let's just make sure my server is also saved. Yes, I didn't save the server. That is why it was printing the message used in the last session. Okay. CD desktop. Let's resize it. So this is my server. And this is my client. So first I'll run py server.py. So it is saying server is starting. Okay, I hope it's visible now. Server has started. Now let's give client. Okay, so it is giving an error. An operation was attempted on something that is not a socket. Okay. So it is giving the error in line 20. This is my server. Okay, it is giving error in this line. I Okay, while connected, connection is true. Con.addr, con.receive if message length. An operation was attempted on something that is not a socket. Okay. Header is HEA. Okay, it should give header. Server is correct. Header is correct. It is saying header is not defined. Right. header. Header is defined. Okay, let's define it inside the function. Okay, still not taking it. Okay, not an issue. We'll close and we will run again. ADDR disconnect message is this. Okay, hello world. Okay, client is also correct. Socket. Then the send message, it should work fine. Okay, let's execute the original scripts and see if it is working. Let's check the ify config. 192.168.0.84. Yes, this is also correct. Okay. Okay, server is starting. Let's execute. cd desktop, cd tutorials, py client. Just check my IP again. If that is changed, 192.168.0.84. That is correct. Okay. py server1.py. client1.py. Okay, so there is some error, and that is an operation was attempted on something that is not a socket. Okay, not an issue. I guess we are missing something. Con.receive header.decode. Okay, so what we will do is we will stop here for this session, and we will fix this error in the next session. Okay, so because this error is coming, so we will handle this error in the next session. So, but I guess you get the idea and the logic behind the session, that there is client which is sending uh, the first message, which is the number of bytes of the data, and the second message, which is the data that it needs to send. There is some error which is saying that it is an operation was attempted on something which is not a socket. Okay, so I'll get this checked and we will fix this in the next class. Okay, so I hope this session was useful to you in some way or the other. Just implement this on your own local machines and see, it should work. I am not sure what this error is, so we will fix this error in the next session. So yeah, tune in into our next session so that we can discuss how to fix this error and what was the cause of this error. We will also discuss that. So that's it for today's session. I hope you learned something. We discussed uh, we discussed what should be the optimal way for client to communicate with server. So the method was to send the number of bytes of data and then send the original data. So then we discussed what is the approach, right? We discussed the header part. We also saw how to close the connection efficiently and terminate the thread. We implemented everything. The last part is remaining, which is to resolve this error and uh, run our socket successfully, right? So we will see that in the next class. So share this video with one of your friends, share this playlist with one of your friends or colleagues or whoever is learning Python. Make sure they also take the advantage of these sessions, live sessions, and keep following. Uh, like, subscribe to our channel, like this video. This will help us and this will keep us motivated to create such content in the future for you guys. So I'll see you next time. Very soon in the next one, we will discuss what is the cause of this error, what was causing this error, and we'll fix this and we'll see how the communications takes place, right? So I'll see you next time very soon. Until then, take care, stay safe,